Good. And we have the chat in the side, which is kind of nice also. Yeah. So I realize since we're kind of a lot of us are doing the web assignment, some of us are not, but for everybody, I thought it'd be nice to have a Google Doc of sorts that I'll share off in the margin. And I think actually, Abbas, you've created a lot of good resources too, that we can kind of collect these and maybe be helpful. So later on, if we have to look back on how to do things, we can see how that is. Basically, just kind of the highlights, like the things like the tables. And if anybody has any suggestions on things that you're doing that work really well, that's a good place to kind of put them so we have a nice collection. And it's definitely a work in progress, and I'll be dumping stuff in there even as we talk today and through this next week.
Any exciting news so far before John shared the items from Tris or Breaking? John, you wanna me share it or you gonna share it the Google that if you need it
I
for
put
this
it over
session?
in the chat on the
Okay,
side.
then everybody can access to that.
Yeah, go ahead and
Very
get
good.
nice. So that's there. I don't think I put anything in there yet about the moon, but all the suggestions for the exposure rates and such are all over there. And I'll keep a track of who's been here so that way I'll try to reach out to anybody who misses a session so that um, we can get caught up. I'll drop the videos in there too. Although that's a good link in itself, is just the link with all the videos is very helpful this
Very good.
week.
Thank you, John. And I think that's going to be very helpful for everybody to be online on the various activity. This week, week 3 of the lab one. Normally, lab one is one week, and this one I intentionally make it a little bit more. I think because that is lab one is the more important lab and gonna be used on the next labs also. It might be beneficial. We spend one more week on that, and that's help any question you may have or any struggle on the activities and. Therefore, to deep dive more on that activities, both Skynet, WebAssign, and also Afterglow activities to see if you succeed on that. Any of you guys have able to submit anything on the WebAssign or had a kind of issue on that? Just feel free to chat or send a message directly on the video.
Okay. I have to make sure I keep looking at the group me also. So Brecklin just hit shared a tarantula. Nebula, very nice. It's so cool, isn't it? When you finally get an image coming back of something that's deep sky, you're like, wow, I did that. The planets are really cool too, and learning how to process all those, but
Yeah, it
pretty
was
tough.
very good that your picture, Tarantula Nebula. Although it's not like a colorful like the one that you see on media, but it is kind of brings the insight what the objects can be done, and that's is actually first step toward the uh, uh, further study of this object and the pictures.
And that was off your phone too, it looks like. Are you folks, have either of you tried to use Skynet on your phones?
Okay.
I took the picture, like I went through the whole process on the computer, but then I found that it's just it's easier to go on your phone, take a screenshot of it than to actually take a picture of it with your phone. So yeah.
Gotcha. Okay, makes sense.
Okay. Yeah. Let me go over the sharing with you on the two topics that we have to discuss quickly. Hopefully you see my screen and here. As you see it on the, what to call it, the pictures that we had here. Uh, as I mentioned, I go review again these items in any object that you're taking in here. For example, if we go one of the specific ones, for example, Mars here. If the basic things that when you here, several things you have to remember. As I mentioned, this one, the ID is on this table. You see ID, name that you assign it, and the telescope that is used, and also the status. And here, if I go to the Mars, this is a 1193-3700 is a specific ID that is assigned for this one. And my ID with your ID, but anybody else gonna be different. That's you see it is 7-digit, oh, no, sorry, 8 digits IDs that is here is specific for that purpose and for the assignment and upload that we're gonna have on the web assign, we're gonna use that. On the, let me see, it seems to be sometime when you encounter, probably you encounter the same issue on the internet. When you go and click, it doesn't pop up immediately. Okay. Okay, here. Then this is the observation ID, and this is a very brief description. You see, we may identify some lengths for the taking the picture, 0.3 second or so, but we just specify multiple telescopes. But here, the result is like this. Is actually the ID that is assigned. This is a different ID here, and you see on the master calibration images that you had bias, dark, and flat, you have different ID here. And the final result also have a different ID in here. Therefore, you have to watch out on those when you're submitting and also providing the data. In here, the also exposure time that you provide, it might be different than this one because at the last stage that program Skynet take a picture, it may adjust that one, and for example, prompt 6, they will take it that way, and that's good enough. Then when you have here several options, that the best one is to download JPG, that you see what is the picture looks like. When you click on that, hopefully you can spot, you see very tiny. You can a little bit zoom it in on by mouse a little bit on that, but it's not very handy here. You just click. When you click one time, it zoom it up, zoom it in. When you click another one, zoom it out. Therefore, that's the only option that you can have it on the Skynet. Therefore, you can take a picture or whatever. You can do that, but the other one is this is kind of information and WITS file and things like that. But the best step is that you go AfterGlow. When you click AfterGlow, and because of that, also if you do it on the Skynet, on the cell phone or desktop, is on the cell phone a little bit tricky because not everything you can see it on the one screen, depending on the side of the tablet or cell phone that you have. But when you click Afterglow, it comes in here. You just click the sign with the same ID of the Skynet, and you go here. And here you check the Mars. For example, you click in here. I think I may go upload also here, or when you have two options. Either you uploaded before, you can see it on this tab on the what to call it, on the Mars, and you can search it. But if you didn't upload it before, you go here and check the Skynet robotic telescope network user ID, and then you search here. On the search here, also there is an option of search here. You can search Mars, and you see which one we just looking for. 1193-3700. I click on that, and normally on this case, you will go directly to reduce image. This is raw image and also master calibration. These two others may use for different purposes on the later stage. But for the beginning, to get the actual image that is needed to be post-processing is a reduce image that we have to click. And when we click again, it comes like a reduced bits file. That reduce means that they reduce the noise and kind of many other artificial things automatically by a Skynet. and you don't do anything on that. You don't worry about that. And then when you click it, it's going to show up on the middle screen. And you see some graphs here, and probably that, oh yeah, sometime this picture may not be in here, sometime on the side, and you will go and directly hit the fits, zoom to fit. And then if it is on the middle or so, you can drag it by your mouse and zoom it in and make it bigger as needed. But on the previous Skynet, you cannot do that. But on the what to call it, the Sky Afterglow, it's easy to do. And as you see it here, it's kind of blurry, but you see very great uh, white cap on the on the bottom of the screen. But it seems to be based on the regular prescription of the pictures. This one gonna be polar cap, and normally it is upside, not in the bottom. Therefore, you just flip it and go upward. Therefore, this is the one that we needed to investigate. And the other thing that I mentioned, specifically for the moons, is very important to just change the saturation level. But here we don't want to take a moon, and therefore our filter is U or something else that is not needed for the taking the moon. And I didn't try to take a picture of the moons of the Mars, Deimos and Phobos, but it seems to be very difficult because they are very smaller and less magnitude. But if you are interested, you can try it to see if successful on that. And in our web assignment, we don't have any activity for taking picture of the moons. But this one, for example, when I make it faint object, you see, and zoom it out, I don't see anything beside it. And I bring it up saturation level percentile. It doesn't show anything because we didn't intend it to take a picture of that object. And you see this polar cap is happening when it comes to the very close to 100% percentile. And when we click it, it's more obvious and clear here. And then the other thing is that you may look through the Stellarium, what the time is taking and what the kind of this configuration looks like in actual picture based on the data from Stellarium. For that purpose, you go to the eye and specify one date is taking. We have several dates here. Normally, if you're taking one of them is good enough for our purpose. Then I will go back to the Stellarium. Let me stop sharing and redo the share. Hopefully you see it. Do you see the Stellarium in my view?
We see Skynet again.
Oh, sorry. I have
That's all.
to I have to do it again. Thank you. Yeah, that's much better. Okay, hopefully you see it this time. And I recommend, as we mentioned on the previous sessions, I recommend to use app downloaded on your desktop or cell phone is better because I believe on the desktop is much better because cell phone area is very little. You may use it, try it to tablet, but it's best option to use it, the one that you see it on the uh, desktop or computer or tablet. In here, first thing you do, you just delete the area that you see it for the landscaping and see like a dark side and several items in here. When you click on the left side, might be on the Apple or other devices, might be a little bit different. I don't have it Apple to check it, but this is one that I see it in my PC. One item is here, location. First thing, you have to change the location here. Then you come here and, for example, you see the location is America, New York. Then you will check here something like UTC. It has come, no, it doesn't come. But normally when you come here, when you search at UTC, you cannot find it, Universal Time. But it's better to come here on this folder tab here. And here you will see it UTC. And UTC with plus and minus, and you have to find it, the one that is 0. Here is 0. Therefore, and you can check the default location if you need it, but for our purpose in here, we needed to have UTC identified here. And then after this first one that you identified the location, you go back and specify the time. Okay, then we have to go back to the, this we have to, there is no kind of things, I believe we have to go back and forth between the picture. We have to close that by the icon here and go back here and see the time. And we have to write it down in some piece of the paper. I think this is one of the key things that might be in new versions of the either Stellarium or AfterGlow, it might be better. Therefore, we have to remember or write it down in piece of the paper. It is 10th of the December 2024, 7:42 UTC or GMT. Then we go back to the previous. Let's see. You see my desktop scenario, or I have to redo it again?
We're in AfterGlow right now is what we see.
Okay.
A
And I
couple
have
notes
to.
going through this. Yeah, the browser is much different than the downloaded version of Stellarium. So it really is like learning two completely different programs. But my experience on a Mac and a PC, that the downloaded looks virtually the same. I like this of being able to go to UTC 0 because that is what's in Afterglow for the information that's given to us. All right, as you're transitioning, boss, I'm gonna go back through some notes, some things we talked about on Tuesday. I want to make sure we kind of, and for might have been shared on a Saturday.
Sure.
But a couple little things. Let's see. Actually, some things I'm going to wait on. When we're looking at those images in Afterglow, when you're looking at Jupiter, looking at the moons, and you change the brightness, so you're overblowing Jupiter so you can see the moons. That's a great way to find them. It also is worth taking a moment to adjust the exposure so that you can clearly see Jupiter. One thing I've caught in the past was a little black dot going across the surface of Jupiter, because that could very likely be a moon. You can locate a moon off of its surface when it passes in front of the planet. So it's kind of fun to look for those sometimes. And let's see what we got here. And we can talk about some of this other stuff later on. Let's see, saturation, all master. Well, yeah. And as far as those images, recap, those raw images and masters, those are what are used by the AfterGlow program. So they're being used. We're not going to use them. But that is basically darts and all that. That's something we can talk about if anybody has any kind of questions as far as what they mean. Yeah, so the purpose of the Stellarium is the Stellarium does a phenomenal job with positioning the planet and its moons as far as where they should be. So it helps you to identify what the moons are. With Afterglow, you won't know. All you'll see is Jupiter and you'll see the bright spots. And you might have some idea about how big they are. And if you've watched them and taken images over the course of a week, it's because they move so fast. If we take an image today and take one this morning, one this afternoon, and take one tomorrow, those moons will not be in the same position. Our moon takes 27 days to go around, right? 27.3, it's like a month for a moon to go around. Jupiter, that's not true. They go crazy fast. And so they're always changing position. and they'll just shuffle which one's looks closer and farther, but by the orbital position. So that's why we kind of have to have some kind of reference, and Stellarium is a good enough program that it actually allows you to do that.
Yes, thank you, John. And also, as I mentioned here, after you specify the location, you go to the time. It was 2024 and December, and it was 10. And you can also highlight and change it here with your mouse. And might be more faster. And the time is 7. It was 7 and 42. And second is not very important, but because when you specify here, it's gonna change. Therefore, it's gonna be location, it's gonna be changed. Therefore, you just put something here, 17 is good enough, as long as it's good. And then after you specify the time and you double check to see the time is correct, and then you go to the here, find the search window, and you say Mars. Here, you just identify the Mars, and you close this one, and you just bring it up on the as close as possible. See this picture here, you compare it with the picture that you see in Afterglow is correct. This polar cap is slightly leaning toward the left as we see it on our picture. And also this two moons are nearby, but we don't see it because the picture that we're taking is not observable on here. Then we keep this one in here, and then we go back to the previous what to call it slide, and hopefully you see it. You see it Afterglow here on the screen. Yeah, okay. Then the one of the things that we're gonna see, you have to kind of you have everything here ready. You don't need it to memorize. When you submit the, for example, Afterglow, here you come here. I view it as a kind of a student in here on the lab, Skynet. You go to the observe the planet procedure, and you have instruction here. And here you have to identify the Mars observation. For example, you say it uh, 11, whatever you have here. I don't want to repeat it here. And you choose the file. For the choosing the file, you have to remember in here, we have two options. One is the saving as a download viewer. When you click this one, it's gonna show and save this picture. When you click this one, it's gonna show the, we'll try it, very small, the one, first one that you see it on the, when you uploaded the picture. When I click, for example, here, JPG, you see the picture is very small, the one that we see it on the Skynet and beginning of the Afterglow. But when you click this one, you see it, the larger one, Afterglow, the one that we needed. This one has to be submitted in here. Therefore, when you upload it, you just upload the one that you needed on this section. And then we go to the next step to get the submission of the size. And we said if you are today, although this is December, but right now is also Mars observable, you can say it here yes or no. And the telescope it used is a prompt 6 or some other thing. And the date and time, for example, you put 12, 10, 24, the one that is picture, or yours, whatever you have. And the time is 7 and 42, 14, something like that. And you see the this format of the presentation is given here. You don't need it to memorize anything. And then we're going to come angular size for the diameter. That is here. Then we go to the here. On this option, I said this is kind of show the display and the graph of the pixels. Here it gives you some information on this tab on the right. And the next one is important is the one that is showing here as a kind of platter. In here, you come down a little bit. You will specify clicks. If you want to click the centroid or planet centroid or interpolate the pixels or synchronize the plot across the files. And you have to find the best option for the choice that you needed. If, for example, you want to take a picture from the center line of the planet to the center line of the moon, probably you will use centroid. Click or planet centroid is good. But when you want to ask for the diameter, this might be a little bit tricky. Let me try. And therefore, let me see. And then here you click on this side. It create sometime it doesn't succeed. Here is not good. I remove this one. Yeah, you see, when the diameter you want to check it, you don't have to click those. Only synchronize plot across the file. And here you see we don't know the very edge boundary of this location very clearly. Therefore, we have to use it in a way that it goes as much as close as possible. Here, for example, it seems to be this all right. And we go down, and this is a measurement that we're taking here, 12.84847. We just record this one in piece of the paper or on our sideline, arcsecond. And we have other links, but those are not important for us, arc minutes or pixels, but we wanna only check the arc seconds. Then we go back to the lab and enter in here the amount that we have, 12.847. And then you just provide your name here to attest that you already did yourself this one, just kind of formality for the system. And on the next procedure that we are doing right now for the error percentage, whatever you calculated, you measured, you're gonna be this one. And this is the professionally best determined value is the one that you get it from the Stellarium. Therefore, you just provide here 12.847. And here, when you put the number, is try to put minimum 3. You see the correct, the diameter is arcsecond. You have to put 3 significant digits. 3 significant digit minimum is like this. You can do it like that, or you can do it more than that if you need it. And then you calculate the amount in here, the error. It means that how much the professionally best determined value. They go back to the Stellarium, and hopefully you see it. Oh, what happened? Oh, I
Right, yeah,
close it.
I'm still seeing the other. Just make sure he's really clear on that. So when you click on the Stellarium image, it'll give you all that information. And among that information will be what they think the size is. And that's your comparison.
Yeah, let me do it again.
And one thing we'll try to do as a boss, we do this 3 times a week, is we'll try to make sure we don't skip things that we talked about in other sessions. And he's doing a great job going through things. And I'll try to touch base on a few things. I'm keeping notes here too. And if you have questions, do ask. Keep asking in the chat area so we can kind of answer those as we're going. As a boss is pulling this up, a couple things just to explain as we go through this. One will be arc seconds, but also the different formats. You'll have options. The JPEG, the PNG, those kind of files are very compressed, which means it's using a mathematical algorithm just to save file size. And so it doesn't really tell you what every single pixel does. It's more of an approximation across the field, and you lose information. The FITS does not lose anything. It's raw. It's everything, every little pixel, exactly what it is. Plus, it has layers of information for each pixel, and it has another information layer that page that a boss has been going through. It has all that information. That's from the fits file. It's all stored in there. So when you kick stuff out to us, we really don't want to see the fits files because they're huge. We'd rather see what you come up with as far as a PNG, and that's what you'll be sharing. But the fits are very handy in astronomy for so many other things we do.
Thank you, John, on that. Let me go to see.
As you're trying to open that up, okay, if I share real quick and go through a couple things on AfterGlow.
Yeah, go ahead. Go ahead.
Okay, I'm gonna try to pull this up too. So let's see if I can share the one I want. I think this is it. So I think now you can see my AfterGlow page. Is that good?
Yeah.
Okay.
I see it.
So I made a couple comments like this is Jupiter. I hit faint target. I see the moons popping up above a little bit. I see if I go default, and then I go to bright, and there it is. So there's Jupiter right there. And if I look at, oh, if I hit the zoom, that's the better way to do it sometimes. I have more control over looking. And I don't see any black dots. I often look like that. One in the middle looks like a bit of one. But this is one way you can sometimes identify moons going across the surface if you watch those dots over multiple frames and they appear, then they disappear, or you can watch them actually move across the surface. It's a neat way to find another moon. But I'm going to zoom back out, and we have features like rotate. So I'm going to rotate this around. And what I want to do is uh, a couple of things the boss has actually you've shown me is by going to I'm gonna go to faint target. I want to get those moons, but I can change like the mid-tone level, and that will actually help more things start to pop out. So I'm going to zoom in here. What I want to do is see these moons. I see 3 moons off to the side here, I think. And I zoom in a little farther, now they're starting to show up. By adjusting the midtones and by adjusting the saturation levels, you can really make it clear that, there they are. And then with the plotter tool, that's a neat tool to, as you want to get the size, you can click on one side and go across. I like to go a little extra each way. And the disadvantage is when you do that and you come over to the side, when you look at all your data, it won't show you the diameter of the planet. You only do that if you go from edge to edge. But I can actually look at this data in the plot, and it'll tell me where one edge is and one other edge is. So I can figure out mathematically, I can subtract those and figure out how wide is this object that way. So I found that kind of handy. But also for the moons, I like to, if I'm making sure I get a moon, I just come out here with my little plotter. And if I drag across one of those moons, I should see a little blip appear. And that helps me affirm that, yep, there it is. There's a little moon off to the right. Here's another moon right there. There it is off the right. And this one out here, is this a star or a moon? I come out here and I look and I see a little blip. There it is. Okay, but I got 3 moons. So it's a neat way to kind of double check these. I'll show you one more thing while I'm at this. Let me go back to my eyeball and change it to bright target. So now I'm looking at Jupiter. If I use the plotter and I scan across the planet, boy, I think it's finicky. I like to look at the plot to kind of see, does it have a nice feature to it? And how bright is this? This is about 3,500. And that gives me an idea of how my exposure is working. And I can see the storm clouds of Jupiter as peaks in here. If I had taken this image and it was just flat topped, that would tell me that my exposure was too long and I just maxed everything out. So you really want something that has nice features to it if you want to see the quality of image you can have and want to get as close to saturation as you can. I've had some images where I was down around 1,500, and I know I should have done a longer exposure. And then I have some that hits, I forget what the max is. It's way up there, and it just looks like a hat. It just comes straight across. I realize, oh, I went too long. And you really won't know until you get your images back. But that's been very helpful for me.
And I also thank you. There was a question on the chat. I responded, but I think if you are on the page, you can show it okay, I will show it. The one that the question is that which JPEG do we gonna share the JPG or other ones? Let me show it to you that way. And here, as we see it,
It's funny we use JPEGs. JPEGs are great. PNGs, I think, are a little better suppression just for reference.
Yeah, here is the one that you see it. Hopefully, you see my Afterglow page here. There is a two icon in here. You wanna share it. One in on the left side, one on the second to the left, and this one is the whatever export image that is comes from the Skynet to the Afterglow. That's the first small Mars that you see it. But when you do the post-processing and enlarge it and you measure it like this or whatever you do it, this is the one that you view that you see it here. The most leftmost icon is the one that you have to download. Then you click this one and you download it here. This one, JPG, you name it or whatever you need it to be very specific for your purpose. For example, you can add your initials here or date that you did it, and then you download that. You upload this one to the WebAssign in here on this what to call it, place that asking for the upload. I think in here, choose the file. This is the picture that you want to get it. I hope this answered your question and clarify it. Just let me thumbs up if you get my point, or you have more question. Okay, thank you. And then the next step is the, as I mentioned, let me see, we can go and do the Stellarium. Okay, then I share it again. Hopefully this time this goes well. Okay, then you see the Stellarium picture again. I'm just double checking, make sure when we're transferring everything is all right. Here we go. I have to redo it again from the beginning. The time zone, we go UTC 00. There the one. Then the next step, the time 2024 12 10 times 7 42. And the second is not important. Then we come here, specify the Mars. We already have it here. And close this ones, enlarge it. Okay, here, in here, you can see this enlargement is only, you don't need it to, for the measurement, you don't need it. Only you need it to see orientation that you have on the picture is a similar the one that is based on this professionally a picture that is already available. On the left side, you see some many information facts about the Jupiter, sorry, on the Mars. But in here, you will find it apparent sidereal time and other things. But the one that we're looking for, the apparent diameter. As you see it here, how much the apparent diameter is? Can you help me out on the reading? Or very small?
It's really small on the screen, but
Yeah, it is, but you can find it. Apparent diameter here is 12.51. You just write it down, 12.51. And we go back from this one. This was only thing you needed to enlarge it. For enlargement is needed only to see the orientation, how it looks like in your picture compared to this actual professionally uh, picture that is available on Stellarium. But the other thing that you needed to check here is only apparent diameter is 12.51, and it may not change in the few minutes or few hours when you normally on this object. But if it is takes more time, you may find that this also going to change. And we go back here to the Stellarium. Do you see the page of the Afterglow in my desktop? And WebAssign? Okay, good. Here, then we come here, then you get the data 12.84, and whatever dimension we get it from the Stellarium is not 1284, 12.51. And then you calculate this what you have it here, and you put the name here, for example. I put my name here, and then present the percent error calculation here. For example, the one that you had it here, the formula is given, your value, professional value, and divided by professional value. It's gonna be like 12, 12.847 minus 12.51 divided by 12.51. You have to put, you cannot put absolute value, but you can put it like absolute, something like that. Absolute value. And this, you can calculate it with your calculator. It's going to be,
That's actually really good. You're very close with the
yeah, it
that.
is. I mean, that's amazing that I don't expect. But you normally sometimes on the very faint object, it's going to be uh, more than several 100% difference. And therefore, that's here, the error is going to be 2.7%.
2.7%, 2.69. That's very,
Oh,
very close.
6, yeah. Yeah, and you put always 3 significant digit, 2.64%. It's very good. I mean, that's exciting that you see it. Your numbers might be something different, 1.2 or 3.7 or 7.8. All of them is very good, reasonable accuracy. And then here you provide some your thought about what kind of source of the error might be happen. And in here, we have a description on section B1 that guides you. If we go back section B1 and here, uh, B1 here. You see this one, they give us some information about the, what to call it, how that gonna be this zooming and also taking the measurement might be creating the problem. And then based on this write-ups and information, you can give us on, on this one what the source of the error gonna be. And we don't care about the human error because here human error is not measurement error or calculation error, and it's not valid source of the error because whatever we have it here is errors related to the kind of inaccuracy. For example, if we go back here, one of the errors probably is the one that we don't have any clear age for that picture. That's because of the type of the picture that we have it. And then if we make it kind of little bit different, like go back here, we say bright object. And also this is the brightest object, but still you don't see very clear age on that. Some of the planets are big enough, for example, Jupiter and Saturn, you're gonna have a better picture. For example, let me show you another one here with one of the Jupiters. So And let me show you something on the Saturn, because Saturn also one of the key items that we're going to look through it. When you see the bright object, you have very clear, a better clear age for that. And normally when you do that, you have to, for the Saturn, remember, only you needed to take picture from age to age of the rings. For example, in here, you click on the plotter. And this is the kind of show the size of the rings. As you see it here, this area is higher light curve. It shows the main kind of circle of the planet itself. Here, as you see it, the light is bumping here on this side and this side is related to the rings. But we don't need it only the planet, the size, but we needed all of them together. Therefore, you come down and see this is 36.67. This is the one that we needed to use, and in this case. And let me go and do the Jupiter as well. One more time. You go here, observation, Jupiter, and you have Jupiter here. Open, reduce image, waiting to upload. Okay, and then you come here, you say bright target, zoom it in. As you see it, age is more clear than the Mars that we had. Then we go to the plotter. Here, click one side to the other side. Therefore, here, or if it does not have, you can try to see if you get different values on different locations, different orientation. Here, for example, 44.7. Here is 46. You see, it slightly become different because the reason is that we don't have any accuracy on this kind of measurement, like the one cursor and the what to call it. We just, sometimes we just miss at the age when we click, and that kind of errors is very good. It is very good from this sense that you can check it directly from Afterglow how those are different. If, for example, you miss at the center line, you may come up with kind of like this. This is not goes through the center of the Jupiter. Therefore, it's not going to be angular size. It's going to be lower value, 43. Or you do it like this, it's going to show the different value. But as close as possible, you are on the center, it's going to be better. But we don't need it to go that much detail. As much as you feel it from your eyesight, it is on the center is good enough. And then you come back and provide information here. For example, you, on the Mars, you did it, and provide some, whatever it comes your mind. This is kind of brainstorming for you guys to understand what the error originated from. It's not for purpose of degrading or doing something like that, but it is more insightful for your learning to understand that what is happening on this images also. And the next item that we're gonna go on the next stages about how to marking the planets and also the moons. If we go back here, for example, if I wanna look through the Jupiter, I will go back again on here on the observation and search for the Jupiter. And I specify ones that I take a moons also with a specific name to understand those are how it looks like. Then I click and wait for it comes. As you see it, as also John mentioned on his picture, you just bring it in the middle, enlarge it, and you use the option that you have it on the, what to call it, bright, bright target. You see it moon, but faint, you just bring it a little bit, the saturation level up to see it more clearly and less noise. I think here might be a little bit better. Then you go and identify the time. And again, you do the same thing. You specify when you bring the time and check with the Stellarium, you will see the orientation and you can change the orientation to match with the Stellarium. And you find what, for example, planet moons are there, either Europa or Ganymede or something like that. Then to mark it up, you have to go and come here. platter on the what to call it? Let me show it here. Centroid, click and planet centroid, and you can do that. And then when you click, this is kind of customization marking where you want to provide marking. You will do that. You just provide click on the centroid and play it on the center. For example, you don't see it anything else, but the other thing's gonna comes after you click on the center. When you click on the center, then you another click. When you do another click, it comes the marker customization. For example, you see this is Jupiter, and you see the Jupiter is written on the picture, but you can enlarge it a little bit more if you need it. And then here you can change the radius that the what to call it, the market gonna show, or the things like that. But if you wanna, for example, for the smaller object, you can reduce it like this to be representative. And also label location. You can just make it a little bit farther from the planet or something like that. And you do the same thing for the other object. For example, this one. You mark it first, it's circular, and then mark it. For example, this is you, and identify you, and the other one. You have to do two times click, and then Ganymede, for example. And then that's it. If they are very close to each other, you have to play with the radius and location, direction in here. This three option is very useful to, for example, if they are very close to each other, to put the name accordingly on the other side to be visible. And then at the end, you just download the viewer picture. And this is the one that you have it, and you can upload on the WebAssign that you have it on here. Here, you can choose and upload, and the universal time and the date, and as well as ID that you're using. The ID is the one that you already having used for the objects. Any questions so far?
I made a few comments in the tabs, and thanks for going through that. It's a lot of fun marking these up. I made a little comment. You can invert and do things like that with the images. And as you adjust, moons will appear, they'll disappear, and all that kind of stuff. So you're going back through my notes real quick, see where we're at. If I want to, I'm going to share real quick, if that's okay, in AfterGlow. Do notice, like when I open multiple objects, they'll be up across the top on different tabs. This makes it really easy to jump from one object to another if you leave them open. So I can look at Jupiter, I can go back to Venus and stuff and check it out as you go. And that's kind of nice, so I can compare two different images. Like I had a couple images of Mars to see which one came out better and all that. Okay.
That's good point. That always we can have all of them ready, and you click the one that you needed on the top and show it the object that you measuring.
And a question we did get last Saturday, I believe, was about angular size. Just making sure you understand what's going on here. Is like if we're looking at the angular size of the moon, it could have the same angular size of, say, a plane, if the plane is a lot closer to us. So we're not measuring distance away from us when we do it. It's that we have 360 degrees in a circle, and each of those degrees breaks into 60 minutes, and each of those minutes breaks into 60 seconds. So that's a degree, 60 arcs minutes, 60 arc seconds. And we're just looking at how wide they appear in the sky. And we'll later on use this with a term what we call parallax to figure out how far away things are. But that's like we're going towards that. For right now, it's just about figuring out how wide do they appear in the sky from the Earth. And so we're measuring this arc sign is from these telescopes here on the Earth. What do they look like? So like if somebody on Mars was looking at our moon, you'd have a really small arc size, much smaller than us because it's a lot farther away from them than what we are. So just any questions about arc size, arc degrees, or I hope, is everybody okay on that one?
Yeah, thank you, John. And also, I would like to add one more thing on that, that normally you can see it on the object on the earth as well. For example, when you're driving the car or not, I don't recommend when you're driving, look through the object, but as a passenger, somebody driving and you look through the side, you see it, for example, a train goes very far distance near the mountain, and you see the mountains are very small on the horizon. And also the same thing, but the tree beside the roadway is much larger and may cover the train or a mountain far away. And that kind of things, when you look through far distance on the regular on the earth, you can see it. And that's one of the oldest way that they calculate the distances and dimensions on the old times, on the ancient by the scientists. And we can provide Aristotle way to calculate the earth uh, perimeter on the next lab, and we're gonna bring it more on live this kind of measurements. Thank you, everyone. We are right now on the top of the hours 10. Any further question left, or you are okay with the objects and discussed? Hearing none, and I hope you guys doing well and exciting more and having fun with the pictures and measurements, and hope you see you on the next session
Yes, and
and
feel
the
free to
next
reach out. Any questions, put them in the chat or get on the group me, just kind of post them out. We'll try to help each other out. And that Google Doc, feel free to drop stuff in there. We make kind of a living document, kind of a cheat sheet for everybody. So we know how to do this or anything you're learning. And there's a lot more. We could probably go another hour, just little tips and tricks. But I'm glad everybody joined us today. Good to see you this morning. And
Good
we'll
to
catch
hear. And also remember, you can contribute also well, in addition for all of us as a kind of a team. We are working at the same page. Hopefully, we get closer to the scope of this curriculum. Thank you, everyone, for joining, and have a great day.
Yep. See ya.